Have you ever wondered how a tiny little spark, something you could barely even see, can explode into a raging inferno that moves faster than a person can run? Well, today we're going to break down the powerful and frankly terrifying science behind one of nature's most destructive forces, the wildfire. This statement gets right to the heart of it. And it's not some kind of exaggeration for a movie. It is a stone-cold reality. That incredible transformation from something tiny to something utterly unstoppable, that's exactly what we're going to unpack. And the key is to realize a wildfire isn't just one big flame. Oh yeah, you got to think of it less like a cozy campfire and more like a weather system. It's this dynamic, almost living thing that feeds on its environment. It's powered by a whole combination of forces all working together to create something truly immense. So to really get a handle on the system, we've got to start with the basics. So how does any fire even start? I mean, whether it's in your fireplace or out in a massive forest, it all comes down to a really simple fundamental recipe, one that scientists and especially firefighters know like the back of their hand. Yep, it's called the fire triangle. It's super simple. As you can see, you need three things. You need fuel to burn, you need heat to get it all started, and you need oxygen to keep that reaction going. If you take away any one of those three things, the fire goes out. But here's the thing. In a wildfire, these three ingredients don't just sit there. They interact in incredibly powerful ways. All right, let's zoom in on that first ingredient, fuel. When we're talking about a forest or a big grassy plain, what exactly is burning? Well, fuel is literally everything from the dead leaves and pine needles on the ground to the grasses, the shrubs, and yeah, even the giant trees themselves. But the most critical factor isn't just what the fuel is, it's how dry it is. Think about this for a second. Fuel that has just 5% moisture can burn up to 10 times faster than fuel that has 20% moisture. When fuel is that dry, it ignites with hardly any heat and just releases a massive amount of energy in a terrifyingly short amount of time. Okay, so we have our fuel, and it's super dry. But how does the fire actually move from one piece of fuel to the next to create that wall of fire we talked about? It actually uses three distinct methods to launch its heat energy across the landscape. First up is radiation. Just think about how you can feel the heat from a bonfire, even if you're standing several feet away, right? That's radiant heat, and it's traveling through the air in these invisible waves. In a wildfire, this radiation blasts the fuel just ahead of the fire, completely drying it out and heating it up to its ignition point before the flames even get there. It's literally preparing its own path forward. Next, we've got convection. As the fire burns, it creates this massive column of superheated air, smoke, and gas. This whole column rises, and because it's so turbulent, it picks up burning embers, little twigs, leaves, pine cones, and carries them high up into the air. These embers can then get dropped way ahead of the main fire, starting new fires all over the place. This is how a wildfire can seem to just jump right over roads and even rivers. And finally, there's conduction. This is the most straightforward one of the bunch. It's fire spreading through direct touch. A burning log touches a dry leaf, which then bursts into flames. It's the slow and steady ground-level spread. But when you combine all three of these methods, radiation, convection, and conduction, you get a fire that's advancing on multiple fronts all at once. Okay, so if the fire triangle and those three methods of heat transfer are the engine of a wildfire, then wind and terrain are the turbochargers. These are the two environmental factors that can take a totally manageable fire and turn it into an uncontrollable inferno in just an instant. Wind is, without a doubt, a wildfire's best friend. It gives it a fresh supply of oxygen, which makes the fire burn way hotter, and it physically shoves the flames and all that radiant heat forward, dramatically cranking up its speed. This is also how those embers we just talked about can be carried not just a few feet, but sometimes for miles, way ahead of the main fire front. Terrain is just as critical. On flat ground, a fire moves at a pretty predictable pace, but look at what happens when you introduce a slope. We all know heat rises, right? So a fire moving uphill is constantly preheating the fuel directly above it. The flames can basically just lie down and reach right up to the fuel ahead of them, causing the fire to accelerate at an absolutely astonishing rate. A fire can race up a hill many, many times faster than it could ever move across a flat meadow. So what happens when you get all these elements working together in this perfect destructive harmony? You've got bone-dry fuel, you've got powerful winds, and you've got steep terrain. This is when we see the most extreme and truly dangerous fire behavior imaginable. Under these perfect conditions, some wildfires have actually been clocked moving at 15 to 20 miles per hour. Let that sink in. That is faster than most people can run. It becomes this unstoppable force of nature, just consuming everything in its path. But believe it or not, even that incredible speed isn't the final form. When the heat gets so intense that the fire actually starts to create its own localized weather system, something even more terrifying can emerge. The fire tornado. And no, this is not just some Hollywood special effect. It's a real documented phenomenon where the intense rising heat and the swirling winds created by the fire itself combine to form a literal vortex of flame. It is the ultimate terrifying expression of a wildfire's power. So the crucial point in all of this is that from that simple little fire triangle to the complex dance of radiation, convection, wind, and terrain, a wildfire is a genuine, perfect storm. It's a powerful and honestly humbling reminder of how small, simple ingredients in nature can combine to create events of immense scale and unbelievable destructive power. And that really leaves us with the final critical thought. We've seen that the recipe for a massive wildfire is remarkably straightforward. As conditions on our planet continue to change, understanding this formula isn't just some academic exercise. It's becoming essential for our survival. So the question is, what does it mean for all of us when the ingredients for these perfect storms become more and more common? Thanks for joining me on this explainer.